Hey everybody, it's Mr. Carr again. Today we're going to be talking about 8-2, adding and subtracting rational expressions. Although today we're just going to focus on adding. So you've talked about polynomial expressions, adding and subtracting those, looking at like terms basically. Now we're going to be looking at doing with our rational expressions, which, bringing back this term from the past, determine the least common multiple of polynomials. That's going to be one of the skills we need to do then for that. And that's going to lead us to adding today. And then next lesson we'll do is subtracting. Okay. But first thing we want to talk about is finding that least common multiple of monomials and polynomials. So we want to find the least common multiple for these three right here. When looking at these, the least common multiple has basically two parts to it. It's got the least common multiple of the numbers. And then there's also the least common multiple of each variable. Okay. So if I start looking at like 15, 16, and 20, we want to find the least common multiple of that. So 15, 16, and 20. So we're looking for numbers that all three of these will multiply up to. So let's see here. So that's going to be probably a big number here. So we got 15. Sorry, I'm going to pause real quick. Okay, so I'm going to show a little bit differently than doing least common multiples in the past, possibly on this one. Basically, I'm going to break down each of these numbers. So if we take 15, breaks into 3 times 5. 16 is actually, I should be able to leave it as 4 times 4. And then 20 is 4 times 5. So when you look at these, anything that's in common, we don't have to like repeat. So unfortunately, actually, nothing is in common between all three of them. So because of that, we're going to have this factor of 5. So we're going to have the 5 in there. We're going to have a 3 in there. And then we'll have a 4 and an extra 4. That should, let's see here. So basically, if we take 3 times 5 times 4 times 4 times 5. Okay. So we have multiply all these numbers together. We should get a least common multiple of this. 3 times 5 times 4 times 4 times 5. It's going to give me 1,200. Let me pause again. Okay, sorry about that. I'm going to make a slight adjustment here because that's going to be too big of a number. And what's going to actually help if I break these down further. So for example, with 16, this actually breaks down into 2 times 2 times 2 times 2. And then 20 is going to be 2 times 2 times 5. Okay. And so the reason I'm doing that is it makes it easier for looking for those common things. So again, I already have these. Whoa, don't want to do that. I have these two in common with these two. So I'm going to put a 2 times 2 in my least common multiple. I got a 5 and a 5 here, so I can put a 5 there. And then I still have a 3 and then 2 more 2s. So I'm going to do those 2 like that and a 3 right there. This will give me my least common multiple of the numbers. So 2 times 2 times 5 times 2 times 2 times 3. And that gives me 240. So again, that means that all three of these numbers can multiply up to 240. So for my least common multiple of the numbers, I've got 240. For each variable, we are going to look at the smallest exponent of each of these, because the idea is that if I look at a squared, there's no a here, and there's a to the third here. Okay, so for that one, we're going to look at, sorry about that. So for our LCM there, we're going to look at what is the smallest number that all of these can, right? Sorry, I said smallest exponent. They're actually the greatest exponent because everything else can multiply up to a to the third. Okay. So for example, I could take this times a, that would become a to the third. This can be multiplied by a to the third to become a to the third. So a to the third is part of my least common multiple. If I look at b, I've got b to the fifth, and then no b here. So b to the fifth is my biggest one. That is part of my least common multiple. And my last word is c. So we got c to the third, c to the second, and c to the sixth. My largest exponent, c to the sixth. So that's going to be my LCM. Okay. So again, the idea of a least common multiple is every one of these numbers can multiply up to that. There's something that multiplies by both numbers and variables. Okay. So that's our least common multiple of our monomial. We can also do least common multiples of polynomials. In order to do that, we're going to start with factoring. I want to factor both of these expressions. So for example, x cubed minus x squared minus 2x, I can take an x out of the front. So x squared minus x minus 2. And then I can factor it one more time, and that's going to be, let's see here, x and x. That's going to be a plus and a minus, and it'll be a minus 2 and a plus 1. Okay. X squared minus 4x plus 4. So we got x and x. That's a minus and a plus, so it'll be a minus and a minus, and that'll be minus 2 and minus 2. Okay, so the idea here is that we are going to look for what's already in common. They have an x minus 2 and an x minus 2 in common. So my least common multiple is going to have x minus 2 in it. Okay, so it has x minus 2, but it also has another x minus 2, an x plus 1, and an x. So all of those need to be represented in my least common multiple. Okay, so again, this expression can become this by multiplying it by another x minus 2. This expression can become this by multiplying it by x and x plus 1. All right, so a little bit of quick check for yourself if you want to try those on your own, but I'm actually going to move on to talk about how this helps us with adding. So adding and subtracting, just the main concepts here. The idea is if we have our irrational expressions, just like with any fractions, you have to have common denominators. So if I have a rational expression as a over b and c over d, then that means we have to turn it into like this BD idea. Once they are common denominators, we can then add the numerators together. And that's our goal with this. Okay, same thing with subtraction. But again, we'll worry about subtraction on the next lesson. Okay, so for here, if we have monomial denominators, and again, we want to turn them into common denominators, we need to find the least common multiple of my two denominators here. Okay, so we'll start with 6 and 14. So I've got 6 is the same as 2 times 3. 14 is 2 times 7. They got a 2 in common, and then we got 3 and 7 as part of these as well. So my least common multiple is going to be 2 times 3 times 7. And that's going to give me 42. All right. For my variables, I've got a squared here and no a, so a squared is going to be part of that. So 42 a squared. And then I got b and b squared, so that's going to become a b squared there. This is my least common denominator that I can turn both of these into that. So again, to do that, we have to multiply both the numerator and denominator by the same thing. It's just like adding, subtracting regular fractions. So 14 needs to be multiplied by a 3. So it's going to be multiplied by 3. A squared, b squared is already a part of it, so that I don't have to do anything else. So my numerator gets multiplied by a 3. Over here, this has to be multiplied by a 7. I'm missing a squared, so I'm going to multiply by a squared, and I got to multiply by b, because b times b is going to give me b squared. This also gets multiplied to the numerator, so 7a squared b. So I do that, and both of these fractions will now have common denominators. So we got 7 times 5 is 35, a to the 4th b over 42 a squared b squared, plus we got 9 times 3 is 27 over 42 a squared b squared. There's no like terms here, but I can combine it together into one fraction like this, 35 a to the 4th b plus 27 all over 42 a squared b squared. Okay, and again, that's the idea. We want to add our rational expressions together as long as they have common denominators. Okay, polynomial denominators will also work the same way. We first have to find our least common multiple of those denominators. But to start with that, we're going to do factoring. So when in doubt, factor it out. So out of 3x and 15, we can factor a 3 out. So 3 times x minus 5. And then I can factor out a 6. So 6 times x minus 5. So for my least common multiple, we're going to look at 3 and 6. Well, that's pretty easy because 3 can multiply up to 6. So 6 is going to be part of it. X minus 5 is also in common. So it's 6 times x minus 5. So both of these fractions are going to be over this 6 times x minus 5. Okay. So then when we look at the first case, I guess we're looking at subtraction on this one. My bad. So we look at this case here. Since this one is already that common multiple, this is just going to stay the same. It'll be 3x plus 15. There's nothing to change there. This one, though, has to be multiplied by a 2 to make it into the 6 times x minus 5, which means I'm going to multiply the numerator by 2 as well. But remember, we're distributing here. So 2 is going to distribute, so I get 2x plus 20, and I'm still subtracting that. Okay, now the other thing with subtraction is when we subtract this entire fraction, we have to subtract like this. So it's the same thing as doing plus the opposite of this. Okay, so the subtraction will actually turn into that kind of a problem, which means I'm going to have a negative 3x and a negative 15 to work with. But the next part is just put my like terms together. So I have 2x and a negative 3x will turn into a negative x. And positive 20 and a negative 15 will become a positive 5. And underneath, I'm going to have 6 times x minus 5. The last thing I want to check for is, can I reduce my, or simplify my fraction, my rational expression here? Just like we did in in 8.1, we check for any kind of common factors. So in this case, because I can also factor out a negative 1 from the numerator, I can do negative 1 times x minus 5. And then I have 6 times x minus 5 underneath. I have x minus 5 and x minus 5 as common factors. So they cancel each other out. So in the end, this factor simplifies into negative 1/6. Okay. There's a couple more examples you want to try on your own. So there's that one there and that one there. But that is it for today. So again, the basics of our adding and subtracting, we have to have common denominators first. Then we can just do our adding subtracting with our fractions. And we just do the adding subtracting with our numerators. That's the main idea. The other part of that main idea is that how do we find our common denominators? We have to find the least common multiple by doing both numbers and polynomials or variables. Okay, that's it for today. Take care, everybody.